Hi everyone and welcome back to Maths and Physics with Mr. Simons. Today's grade 11 lesson is on energy and change, and we're looking at November 2020's past exam paper. First variation of 4 variations that we tested. We're giving you 2 reactions plus a tabulated results, and we're going to test questions on that, right? So, learners study endothermic and exothermic reactions by conducting experiments 1 and 2 in which the reactions shown in the table below take place. So experiment 1, we have hydrogen peroxide decomposed to form water in liquid form plus oxygen in gas form. Experiment 2, we have water that decomposes to form hydrogen gas and oxygen gas. Right, now the learners measure the initial temperature of the reaction mixtures. They also obtained activation energies for the reactions from a data table. Learners represented their findings in table as shown below. So experiment 1 there on the top. Initial temperature when we started was 24, final temperature 36. So there's an increase in temperature, which generally means energy was released or given off. Right, experiment 2, we also started at 24, but temperature dropped to 18 degrees. So if we had to touch this object, it would feel cooler. Therefore, that means energy was absorbed. All right. So now let's look at the questions. That's the tables given with the tabulated results. So define the term activation energy. Right, so energy that acts, no, I'm just lying. Activation energy is the minimum amount of energy we require to ensure that a reaction takes place. No? So minimum energy needed for reaction to take place. Right? Which experiment 1 or 2 is the reaction exothermic? So exothermic there you see have colored red, that is to show that it must release energy. Explain your answer. So reaction 1 there on the top, we consider exothermic because there's an increase in temperature. So the temperature of the reaction mixture increases. It went from 24 to 36 degrees Celsius. So when my temperature increases, exothermic. Temperature decreases there, endothermic, right? Is the heat of the reaction delta H positive or negative for exothermic reaction? So delta H is always negative because it will always be products minus reactants, alright? So delta H there is negative, alright? 5.4, write down the general name of a substance that can be added to the reaction mixture in experiment 2 to reduce the activation energy, meaning we want to reduce the minimum energy needed for the reaction to take place. That is referred to as a catalyst. Right, so just to refresh, exothermic reaction, delta H must be negative. For it to be exothermic, the temperature of the reaction mixture must increase. Definition of activation energy, we ask 90% of the time, so make sure you know it. Let's look at the second set of questions. Right, now they say both reactions produce the same number of moles of oxygen gas. So reaction 1 and reaction 2 produced oxygen gas. How does the mass of hydrogen peroxide H2O2 used in experiment 1 compare to H2O used in experiment 2? So they have 2 oxygen atoms. Here I only have 1 oxygen atom. Right, so that molecule of oxygen there will ensure that it becomes larger than when we have 1. So therefore my answer there is larger than. 5.6, they say draw potential energy versus time graph for the reaction in experiment 2. So in experiment 2 there was a drop in temperature. No? So therefore endothermic reaction. Right, so if we draw that, heat of the reaction, delta H must be positive. And activation energy, there we must show where we started and ended. So my reactants, always there, my products. To show endothermic reaction, my products must be higher than my reactants. Draw from where my reactants is, there all the way to the highest peak here, that's my activation energy, meaning the minimum energy needed to break up H2O in such a way that it reforms new products when it releases the energy, right? And the delta H will always be the difference in potential energy between my reactants and where my products end. Right, so 1 mark for correct shape of the graph, 1 mark for delta H correctly indicated, 1 mark for activation energy correctly indicated. So activation energy always from my reactants to the highest point. Right, so please make sure you know how to draw these graphs. You're going to be doing endothermic, exothermic. It's technically 2 graphs. You need to know how to find activation energy, delta H. Later on, we're going to label it with values when values are given. Right, but I know you understand what I've explained, and I'm glad that you're still here and you will partake in the next video. Right, I'm going to do as many as possible. I hope you stay here on the channel so you are able to get all variations. God bless. Bye.